Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for text justification problem. Let's look at the problem description. We are given an array of strings words and a width, max width, and we have to format the text such that each line has exactly max width number of characters in it, and also they are fully justified, left and right justified. Okay, and we have to pack as many words as we can in each line, and if needed we have to pad extra spaces between those words. The extra spaces between the words should be distributed as evenly as possible, and if the number of spaces on a line does not divide evenly between words, the extra spaces will be distributed on the left side. And for the last line of text, that line should be left justified and no extra space should be inserted between the words. The word is defined as a character sequence consisting of non-space characters only. Each word's length is guaranteed to be greater than 0 and not exceed the max width. And the input array words contains at least one word. Let's take a look at the example 1. Words array has 7 words and the max width is 16. So each line should be of length 16 and the words are left and right justified. So the number of characters in this is 8. So when we add the example to that with that word sequence, it will be 15 plus there must be at least one space between them, right? So 16, 17 and 18. So it exceeds. So that's why we are not including the example in the first line. So we are just taking only these 3 words, and in total they have 8 characters. So the max width size is 16, right? So the remaining 8 spaces should be evenly distributed. Basically between the word this and is there are 4 spaces, and here there are 4 spaces. Okay, but in this case if you look at it, the example has 7, 9 and 13 characters in this line. Okay, but the max width is 16. So 13 plus 1 space between the words, so 1 here, 14 and 15. So the remaining extra 1 space is there, that should be assigned on the left side. So that's why we see here 2 spaces and here 1 space. And in the case of the last word, this is less than the max width and also it is left justified, and so there are 14 and extra 2 spaces we have to add. Okay, so that's why we see here 2 spaces added. So the rules are simple. So the maximum length of each line is equal to the max width, and the spaces between the words should be evenly distributed. If there are any extra spaces, then we have to include them on the left side of the line. Okay, the constraints for this problems are the length of the input array is ranging from 1 to 300, and the individual words length is ranging from 1 to 20, and the words consist of only English letters and symbols, and the max width is ranging from 1 to 100, and the length of the individual string is less than or equal to the max width. Let's look at the approach to solve this problem. So we are given this input words array which has 7 words. This is an example of text justification, and the max width is equal to 16. The expected output have 3 lines. First line is this is an, and for there are 4 spaces in between, and example of text. So in that between example and of there are 2 spaces, and between of and text there is 1 space, and the last line is left justified and it appended with 2 spaces. So basically we can solve this problem using variable size sliding window approach. So we need to maintain 2 pointers, start and end pointer, and using the end pointer we iterate over the input array, and each iteration we have to check whether we can include the current word pointed by the end pointer. Okay, and as basically we need to maintain so far how many characters we have seen in the current window between the start pointer and the end pointer. Okay, and also we need to account how many spaces so far we have included between the words that are seen so far in that window. For example, here there are 4 words. Between the 4 words there are 3 spaces. Okay, so the space count will contain 3, and the character count variable contains 4 plus 2 plus 2, 8. So now we are in end pointer points the word example. So now we have to check whether the accumulated characters including the current word exceeds the maxed width. Okay, so basically we have to, each iteration we have to add so far accumulated character count and so far accumulated space count and the current word length. Okay, so if that sum is less than the max width, then we can include the current word. Okay, so the current word will be part of the window. Otherwise, if that sum is greater than the max width, then we should exclude this current word. Okay, so what we have to do, we have to form a line starting from the start pointer up until end minus 1. Okay, only these 3 words we have to include and create a justified line like this. Okay, and in the case if that including this word is exactly equal to the max width, in that case we can create a justified line including this word. Okay, basically there are 3 cases. The first case is when we include the current word, the total accumulated the line length is less than the max width. In that case we can just simply increment the space count, basically the additional space we include, right? So for that we have to increment the space count and advance the end pointer. That is case 1. In the case where the line length is greater than the max width after including the example, in that case what we have to do, we have to exclude this word and form a justified line with the words present from the index start up until index n minus 1, not end. Okay, so in that case we have to form a justified line with these 3 words. Then we have to advance the start pointer so that that points to our next line. So this start pointer will point to the word which is pointed by the end pointer. So we simply slide the starting point, so we skip the words which are processed already. And in the case where by including this word the total line length is equal to the max width, in that case after creating the justified line we have to advance the pointer 1 followed by the current end pointer. So basically we processed this line, so the next line starts from the index end plus 1. Okay, so that's why the start pointer will be pointing here. We have to traverse the entire input array, and whenever we accumulate the max width number of characters in the line. So that's what I have written here. First we initialize the start and end pointer to point to the first word in the input array and initialize the character count and space count to 0 and traverse the input string using the endpoint. And each iteration set the last line to true if the current word is the last word in the input, else set it to false. The reason why we have to keep track of the last line is, as per the problem description, the last line should be left justified. So to handle that case, we need to keep track of whether the current line we are processing is the last line or, and then assign the length of the string pointed by the current end pointer to the variable current word length, and we have to assign the sum of the so far accumulated character count and so far added space and the current word length. So these three length combined will give us a line length. Okay, so once the line length is computed, we have to check whether that line length is less than max width. That means the current word pointed by the end pointer can be included in the window. So we add the current word length to the character count. Okay, and then if the current word is the last word in the input list, okay, then we have to create the justified line with the words from the start pointer to the end pointer and add it to the output list, and then we have to increment the space count. So if the line length is greater than the max width, then we have to exclude the current word. Basically, we create the justified line with the words from start pointer to the n minus 1. So we are skipping the current word. Okay, and then add that justified string to the output list. Then the current word should be included in the next line. So we are preparing the character count for the next line. Okay, so that's why we assign the current word length to the character count and assign the end pointer to the start pointer. Basically, the word pointed by the end pointer will be the starting word for the next line. So that's why we are updating this. Okay, and if the current word is the last word in the input list, then we have to create the justified line with the words from start pointer to the end pointer. Otherwise, we have to assign 1 to the space count because we already set up the first word for the next line. So there must be a space after that word. So that's why we are assigning the space count to 1. So the third case is if the line length is equal to the max width. That means then in that case we have to add the current word length to the character count, and then we create the justified line with the words starting from the start pointer to the end pointer and add it to the output list. Once that is done, we have to reset the character count and reset the space count for the next line, and then we have to advance the start pointer after the current word. Okay, so that's why we are assigning n plus 1 to the start pointer. We repeat this process until we process all the words in the input array. At the end, the out list will have the justified lines. Let's look at the flowchart. Input for this procedure is a words array and the max width. Okay, first we have to initialize the start and end indexes and the word count, character count and space count and the output list. Okay, so the first start and end pointers will be set to 0 so that they point to the first word in the input list, and the word count is initialized with the length of the input array. The character count is set to 0 and space count is initialized with 0. The output list is assigned with empty list. Okay, then we enter the for loop. Here we check the end pointer is less than the word count. If it is less than the word count, then we check whether the current word is the last word in the input list. If so, we set the last line to true, otherwise it will remain false. Okay, and then we initialize the current word length and the line length. Okay, so the current word length is the length of the word pointed by the end pointer, and then the line length is computed by adding the so far accumulated character count and the so far assigned space count and the current word length. All these three things, the sum of these three will give us the line length. Okay, once the line length is computed, we have to check whether that line length is less than the max width. In that case, we can safely include the current word into the window. Okay, so that's why we add the current word length to the character count. Then we check whether if the last line equal to true. In that case, we have to call the create justify line function to create a justified line with the words starting from the start pointer to the end pointer. Otherwise, we increment the space count because we have to add a space after the current word. So that's why we increment the space count. Okay, then we increment the end pointer and process the next word. The first case is the line length is less than the max width. If it is not less than, then we check whether the line length is greater than the max width. Okay, if it is yes, that means we cannot include the current word into the window. So we call the function to create a justified line with the word starting from start pointer up until n-1 pointer. Okay, basically we are excluding the word pointed by the end pointer here. So we create the justified line and then we are preparing the next line by assigning the current word length to character count, and then we assign the end pointer to the start pointer variable. Okay, and then we assign the 0 to the space count. After that, we check whether we are processing the last line. If it is true, then we call the create justified line function again to process only the current word. Okay, otherwise we assign 1 to space count because we need to include space after the current word we are including in the next line. Okay, so that's why we are adding the 1 to space count. Okay, so in case the line length is not greater than max width, that means the line length is exactly equal to the max width. That is the last case. So in this case, we add the current word length to character count and call a function to create a justified line starting from start pointer to end pointer. Basically, we are including the current word into the window and create the justified line. Once that is done, we have to reset the character count because the next line is not yet containing any word. That's why we set it to 0, and the space count is also set with 0, and we have to update the start pointer so that it points to the word followed by the current word. So that's why we set n+1 to start pointer. Okay, once that is done, then we increment the end pointer to process the next word in the input array. Once all the strings are processed, then we come out of the loop and return the output list. Next, we look at the flowchart for the create justified line function. Okay, the input for this procedure is the words array, the max width, and start pointer, end pointer, character count, and last line. Okay, so first we initialize the justified line string and space string, and then the space size extra, word count, and space count variables. Okay, so the justified line is empty string, space is an empty string, and space size is initialized with 0. Word count is computed by subtracting start from the end pointer and add 1. Okay, and then the space count will be computed by subtracting character count from the max width. Okay, so once that is done, we check whether the word count is equal to 1 or we are processing the last line. For these two cases, the words should be left justified and no extra space should be included between the words. Okay, there must be only single space between the words. So that's why we are checking this condition. So if this is true, then we start from the start pointer and process all the words until we reach the end pointer. Okay, in each iteration we append the word to the justified line and include the space, single space to it, and then decrement the space count. We repeat this until we reach the end pointer. Once we reach the end pointer, we come out and then we have to append additional space so that the line length will be equal to the max width. So that's why the remaining we have to append the space count number of spaces to the justified line after coming out of this loop, so that the final line created will be equal to the max width length. Okay, so then we return. This is for the case where the word count equal to 1 or we are processing the last line. Okay, so if this is not true, that means we are processing multi-word line and also that is not the last line. So in this case, first we have to create a string that contains space size number of spaces. Okay, because we have to evenly distribute the spaces, so that's why we have to add space size number of spaces to the space variable, and then in each iteration we have to add that space string between the words. Okay, and also if there are any extra spaces, we have to add one space one additional space between the words on the left side. So that's why we check if the extra is greater than 0, then add an additional space to the justified line. Okay, so we do this in this loop until we reach the end pointer, and then once all the words are processed in that window, then we come out and return the justified line. Let's move on to coding. First I initialize the out list with empty slice of string, and then I initialize the word count with the length of the words array, and then I initialize the start and the end pointers to 0. Then I initialize the character count to 0. Then initialize the space count to 0. Then I write the for loop to traverse the input array. Each iteration I check whether the current word being processed is the last word in the input list. If that is true, then I set the last line flag to true. Then I compute the current word length. Then I compute the line length by including the current word length and the so far accumulated character count and the space count. Then I check this the line length with the max width. There are three cases where the line length is less than the max width size, and the second case is the line length is greater than max width. The third case is the line length is equal to the max width. In the case of line length is less than the max width, I add the current word length to the character count, basically to include the current word into the line. And if the last line flag is true, that means we have to create, there are no other words, so we have to create the justified line. So I am calling the create justify line function with the words that are included in that line, and the return value will be appended to the out list. Create justified line takes the words array, max width, start and end pointer, and the character count, and then the last line flag. If it is not the last line, then I increment the space count. Next, for the case line length is greater than max width, in that case we have to exclude the current word. So I am calling the create justified line function with the range start and end minus 1 here. And the return value of this function will be appended to the out list. Then I am preparing the character count for the next line. So the character count will be updated with the current word length, and then I update the start pointer with the end pointer, and the space count will be set to 0. And if the current word is the last word, then again I call the create justified line function with only this current word, and the return value will be appended to the out list. Else I increment the space count. So the last case is where both the line length and the max width are equal. So in that case I call the create justified line function with the range start and end, and the return value to the out list. Once that is done, then I reset the character count and the space count, and then update the start pointer so that it points to the next word after the current word. So I set start to n plus 1. Then finally I return the out list. Next I am going to write the create justified line function. This function takes words array and the max width value, start pointer, end pointer, and the character count, and the last line flag. First I initialize the justified string and the space string. Then I initialize the space size variable to 0 and the extra variable to 0, and the word count with the value n minus start plus 1, and the space count is computed by subtracting the character count from the max width Then I initialize the space variable with a single space, and then I check the case where the input line has only one word, or the input line is the one present at the is the last line. So in both the cases, the justified line, all the words in the justified line is left justified, and also they are separated by single space. So I do that in this for loop. If the current word is not the last word, then I append the current word and the space to the justified line. Otherwise, I just only append the current word to the justified line. And each time the space is added, I decrement the space count, so that after coming out of the loop, I can add that many the space count number of spaces to the justified line. Then return the justified line. So if there are more than one word present in the input line and it is not the last line, then in this case I compute the space size between the words by dividing the space count by word count minus 1, and also compute the extra spaces by computing the space count modulo word count minus 1. Then I initialize the space variable with the space size number of spaces, and then process the words in the input in this for loop. So if the current word is not the last word, then I append the current word and the space string. Otherwise, I just append only the current word. After that, I check whether the extra is greater than 0. This is to add extra spaces to the left part of the line. So whenever the extra is greater than 0, I add one space and then decrement the extra count. At the end, I return the justified line. Okay, I missed the space count decrement. Okay, here I have to add the current word length to the character count, because we are including the current word in the input line. So next I'm going to run the test cases. Okay, there is a compilation error. Oh, I missed the curly braces. Okay, I rerun the test case. Cool, all the tests passed. Next I'm going to submit this program. Cool, this program is accepted. Next I'm going to do the code walkthrough with sample input. We are given this input array which has 7 words and the max width is 16, and the expected output has 3 justified lines. Okay, so first we initialize the out list to empty slice of string, and the word count is initialized with the length of the array, which is 7, and the start and end pointers are initialized with 0 so that they point to the first element in the array, and the character count and the space counts are initialized to 0. Okay, then we are entering the for loop. First we check whether we are processing the last word in the input array. If so, the last line is set to true, otherwise it is set to false. In the iteration 0, the word count is 7, start and end pointer points to the first word, and then this character count, space count are 0, out list is empty, and the last line is false. Okay. Then we compute the current word length and then the line length. So the current word length is 4 and the character count is 0, space count is 0. So the line length is 4. So the line length is less than the max width, which is 16. Okay. So in that case, we simply add the current word length to the character count, and then we check whether we are processing the last line. In this case, it is not last line, so the space count is incremented. So after including this word, we have to include space. So that's why the space count is incremented. Okay. So when we leave this iteration, the character count is 4, the space count is 1. In the next iteration, the end is pointing to the word is. So the length is 2 and the character count has 4. So 4 plus 2 plus the space count 1. So 7, which is less than 16. So we add the current word length to the character count. And then this word is also not the last word in the input list. So we increment the space count. So when we leave iteration 1, so the character count has 6, 4 plus 2, 6, and then the space count for this space and then this space. And the iteration 2, we include this word. So 4 plus 2 plus 2, 8, and then this space and this space, so which is totally 10. So 10 is less than 16, so this word is included. So the current word length will be added to the character count, so it becomes 8, and then the space will be added, so the space count will be incremented to account this space. Okay. And in the iteration 3, we process the word example. Okay. The length of this word is 7. Okay. So the character count is already 8 and the space count is 3. So when we compute the line length, it will be 8 plus 3, 11, plus if we include this word 7, it will be 18, which is greater than the max width. So in that case, we have to exclude this word and we have to form a justified line which include these 3 words. Okay. So that's what we are doing here. So we just make a call to the create justified line with the start up until n minus 1. So start to this till this point, we create a justified line by calling this function and append that to outlist. Okay. So that's why we see when we leave the iteration 3, we have the justified line which includes the first 3 words. Okay. So once that is done, we have to update the character count with the current word length. Basically, the current word will be the first word of the next line. Okay. So that's why the current word is initialized. The character count will be set with the length of the example, and then the space count will be added, and the end pointer will be incremented, and that is pointing to the next word. Okay. And in iteration 4, we process the word off. So already the character count is 7 and space count is 1, and if we include this word, it will be 10, so which is less than 16. So that is added to the window. So the character count will be updated with 9 and space count will be incremented, so it will become 2. Okay. So in the iteration 5, we process the word text. Okay. So the previous character count is 9 and the space count is 2. So 9 plus 2, 11, and plus 4, 15. So 15 is less than the max width. So we add the current word length to character count. So it becomes 13. And we increment the space count because the text is not the last word. So we increment the space count. So that becomes 3. Okay. And in the iteration 6, we process the word justification. The length of this word, so the length of this word is 13. Okay. So already the accumulated character count is 13 and the space count is 3. So if we include this word, the line length is greater than the max width. So we are hitting this condition. Okay. So in that case, we have to create the justified line by excluding the current word, which is the justification. So starting from example up until text, these 3 words will be included in that line and the justified line will be created and added to the out list. So the example of text is added. Once that is done, we update the character count with the current word length, that is 13, and then we update the start pointer by assigning the current end pointer's value, because the current word will become the beginning word of the next line. Okay. And then the space count will be initialized to 0. Then we check whether we are processing the last line. In this case it is true. Okay, the last line is true. So we create the justified line with that single word. So after adding the justification, there will be 3 spaces we need to add as per the problem description. So now the output list has 3 justified lines, and that is an expected output. Next I'm going to do the code walkthrough for the create justified line function. Okay, so let's take the case where the start pointer is positioning at the word example and the end pointer is at end 5. Okay, and so first we initialize the justified line and the space string with empty string, and then the space size is initialized to 0, and so the max width is 16 and the starting pointer is 3 and the end pointer is at pointing at 5, and the character count in that window is 13. Okay, so 7 plus 2, 9 plus 4, 13. Okay, and the last line flag indicates the current this line is not the last line, so it is false. And then first we initialize the justified line and the space string to empty string, and the word count is computed by subtracting the start pointer from the end pointer and plus 1. That gives us 3, and the space count is computed by subtracting the character count from the max width. Okay, so we are getting the number of spaces that we supposed to add in that justified line. Okay, first we check whether the line, the current window has only one word or it is a last line. So in this case both the conditions are false, so we will go ahead and compute the space size. The space size is computed by, basically we need to distribute the space evenly, so that's why we divide the total space count by the number of words minus 1. Okay, so in this case we have 3 words, but we have to add only 2 spaces, so that's why we divide by word count minus 1. So we get the space size at the minimum space size between the words in the justified string. Okay, and then we have to see whether there are any extra spaces. So that's why we do space count modulo word count minus 1. That gives us how many extra spaces there after distributing evenly. Okay, so in this case only one space extra, and the minimum space that we supposed to add between the words is also 1. Okay, then we enter this for loop to create the justified line. Okay, starting from the start pointer and up until the end pointer. Okay, so if the current word is not the last word, then we have to add the space, otherwise we should not add the space. Okay, so in the iteration 0 we process the word example, we append that to the justified line, and also we add the space, single space. Okay, so we have example and the single space, and also we check whether the extra is greater than 0. If so, for each iteration we have to add one extra space. So we append additional extra space to the justified line. So that's why we see two spaces. Okay. So in the iteration 1 we process the word off and we check whether that is the last word. It is not, so we add that word off and then the space. Okay, and then finally in the last iteration we process the word text. So that word, because that is the last word, only that word is added. So we have example 2 space off and then single space and then text. Then finally we return the justified line. Next I'm going to do the time and space complexity analysis for this solution. Time complexity for this procedure is order of n times k, where n is the number of words in the input and the k is the average size of the string in the input and the m is the max width. So in this case, for the case 1, the input has 7 words and the max width is 16. And so basically if we look at the full justify function, so in this for loop the main operation is finding the length, append operation, and then this function call. So when this for loop processes all the words, it computes the length of all the words. So basically if we have the length of the word, the average length of the word in this input array is k, then totally n times k characters will be read as part of this operation. Okay, and whenever we reach the max width characters, we call this function to create the justified line. Okay, so in this function maximum we write the max width number of characters. Basically there are n times k character read operation is performed as part of the string length computation, and then in the create justified line performs m character write operations, where m is the maximum width. Okay, and how many times that create justified line function is called, that is the total number of characters divided by the max width m. Okay, so n times k divided by m. Okay, so the total number of operations performed in this procedure is n times k, that is the read operation, and n times k divided by m times m write operation. Okay, so if we simplify that, it will be n times k plus n times k, 2 times n times k. So we can remove the constant factor out. So the time complexity is order of n times k, where n is the number of words in the input array and k is the average length of the word in the input array. Okay. The space complexity is order of 1 because in this procedure we are not allocating any additional space. Okay. So if you look at it, the create justified function returns the string that is part of the output. Okay, it's not storing any intermediate data. Basically this function also not allocating any additional space for storing intermediate data. Okay, so it constructs the string and that string gets appended to this out list, and that out list is the ultimate output. Okay, so that means we are not allocating any additional space to store the intermediate data. So that's why the space complexity for this procedure is order of 1. Thanks for watching this video. Have a great day.